moving on to 4.4, scatter plots. You probably have seen scatter plots before.
Yes.
I'm hoping today's a really easy lesson.
Me too.
First hour I thought it was pretty easy. And it actually went by pretty quick. It was like a 12-minute lesson. So let's try and knock it out.
How long are our usual lessons?
Like 25 minutes.
Oh, okay.
Yeah. So, scatter plots. A scatter plot is a graph that shows the relationship between two data sets. So my x-axis represents one of my data sets. My y-axis represents my other data set. The two data sets are graphed as ordered pairs in a coordinate plane. One's the x value, one's the y value. Scatter plots can show trends in the data. So like I said, one of your data sets is the x-axis. One of your data sets is the y-axis. One represents x, one represents y. That's why we're able to graph them as ordered pairs. Since one's x, one's y, that gives you an x and a y value to create an ordered pair. Scatter plot is just a bunch of ordered pairs graphed on a graph. They're not forming any sort of line or parabola or any shape or anything like that. They're just a bunch of points scattered over the graph. That's why it's called a scatter plot. Any questions on that? Can I go ahead and move on?
No.
I'm waiting.
You can now. So that's over.
We good now? Moving on. Here's an example. The scatter plot is on the next slide, so I'll get to that once we look at the question real quick. The scatter plot shows the amounts x in grams of sugar and the numbers y of calories in 10 smoothies. And it gives us all these questions. So let me show you the scatter plot real quick. Here's our smoothies. My x-axis is the sugar in grams of each smoothie. The y-axis is my calories per smoothie. Each ordered pair represents one smoothie.
I have a question.
So there's 10 total smoothies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes?
Why is the 0 like that?
Oh, so if you notice, it jumps from 0 to 46 and 0 to 240. Whenever your graph is like that, it just means that there's some numbers between 0 and that number that they're skipping over because they don't pertain to our data. Does that make sense?
Yeah. Okay.
Because that would be a really big graph if we went from 0 and we went up by 4s all the way to 46. And if we went up by 10s to 240, that'd be a really big graph. This helps us condense our graph down just to see the data that we're looking at. That makes sense? So, like I said, each ordered pair, each point on my graph represents one smoothie. And it's corresponding with a certain amount of sugar in grams and a certain amount of calories. So let's look at what it's asking us. Letter A says how many calories are in the smoothie that contains 56 grams of sugar. So what information is it giving me on letter A?
The 56 grams of sugar.
56 grams of sugar. So I'm going to go look at my x-axis and find 56 grams of sugar. Find the ordered pair that's corresponding with that. Then I'm going to go look at my y-axis and see which number of calories corresponds with that point. So 56 grams of sugar, that's between 54 and 58. So let's find the ordered pair that corresponds with that. That would be that ordered pair right there, correct? How many calories are in the smoothie that contains 56 grams of sugar? 270 calories. That's it for letter A. Makes sense? We just found what it gave us, 56 grams of sugar. Find the point. Find the corresponding value that we're looking for. Questions on A? Okay, let's look at letter B and what it's asking. How many grams of sugar are in the smoothie that contains 320 calories? So what information am I given now?
Calorie count.
The amount of calories, the 320, a y value. So I'm going to find the 320 calories on my y-axis, find the ordered pair that corresponds with it, and then find that corresponding x value. So let's look at our y-axis whenever it pops up. Find 320. That's way up here. The corresponding ordered pair is this one right here, correct? So how many grams of sugar are in the smoothie that has 320 calories? 70. Very good. That's it for letter B. 70 grams of sugar. Does everyone see how I found that? 320 calories, 70 grams of sugar. Questions on B? Let's look at letter C. What tends to happen to the number of calories as the number of grams of sugar increases? So as my grams of sugar are increasing, what's happening to my calories based on my order pairs and what they're doing? It's also increasing, correct? So as my sugar is increasing, my calories are also increasing. So I'd say the amount of calories is also increasing. Any questions on C? That's it for letter C. Questions on example 1? Not too bad? Pretty easy? Can I move on? Identifying correlations between data sets. This is the last topic for today. A correlation is a relationship between data sets. You can use a scatter plot to describe the correlation between data. So on our previous one, as our x value was increasing, our y value was also increasing, correct? This is what we would call a positive correlation. If you notice, it looks like these points are all clustered around one single line, correct? Like I could draw a line right between all that data. What would the slope of that line be? Positive or negative? Positive. So that's how you can kind of remember it. If the line would have a positive slope, that'd be a positive correlation. Same thing here. If it's going downhill from left to right, what kind of a slope is that? Negative. So as x increases and y decreases, that's what we would call a negative correlation. I can't talk today. Does that make sense? Sometimes on a scatter plot, though, points will be all over the place. We'll have some points up here and down here and down here and up here. That would show no correlation because the points show no pattern. They're not all clustered around one single line, are they? They're just kind of all over the place. So we would say that one would be no correlation. So there's positive, negative, and no correlation. Any questions about correlation? Not tomorrow, we won't be here tomorrow. Monday, we'll talk about lines of fit. That's what this is called. Whenever you draw a line through there, it would be a line of fit or a line of best fit. We'll talk about that on Monday. Can I move on to our last example?
Yeah.
Or are we still writing? Still writing? Okay, I'm waiting. Good? So example 2, tell whether the data show a positive and negative or no correlation. Letter A, age and vehicles owned. So my x-axis is the person's age in years. My y-axis is the number of vehicles owned. Do I have any correlation here, positive, negative, or is it no correlation?
No correlation.
No correlation. They're not all clustered around one line, are they? At some points down here, and up here, and up here. There's no correlation. Questions on A? That's it for A. Letter B, I've got temperature and coat sales at a store. X-axis is average daily temperature in degrees Fahrenheit. Y-axis is coats sold per day. What kind of correlation do I have here? Negative. They're all clustered around this line that's going downhill from left to right. As my X values are increasing, my Y values are decreasing. So this one would be negative correlation. Golly, I can't write. Negative correlation. Questions on B? That's it for B. Questions on example 2?
No.
Can I move on?
No.
Here's our assignment.
That was 1
Page 203, numbers 1 through 12 all. You complaining? I'll bump it up. This will be due on Tuesday, April 20th on Canvas. Most of us should be able to finish this in class today. Due on Tuesday on April 20th.
Will you put it on tonight or tomorrow?
I may try to do that real quick. Any questions before I stop my recording?